All right, folks watching this is like Megan and Remington and Ethan, right? Is that everybody? Yep. So this is the assignment for this section. This is section 6:6. I mean, um, we're gonna do number 3 together. 3 is a proof. So at the end, I don't like the proof that's example 2. We did it this morning. I don't care for it as much, so we'll do number 3 together, and then you'll just have to do the other ones for homework. But this is the last section of the chapter, which means tomorrow we start review, and I will give you that review, and then we'll probably test on Monday or Tuesday, one of the two. We'll see. We'll probably do some more review on Monday, like a whiteboard review, or maybe we'll play a game or something. I don't know. And then we will test on Tuesday. Okay. So there's that. Any other thing that I need to add? Okay. So we're gonna skip some of these. Like we're gonna skip example 4. We're gonna skip example 2 because I don't like that proof. We did it this morning. It's an okay proof, but it's kind of hard to follow. So we'll just do number 3 instead. Okay. All right. This is inequalities in 2 triangles. Yesterday we did inequality, not yesterday. Yeah, yesterday. We did inequalities in 1 triangle where we were talking about like when you have a 50-degree angle and a 70-degree angle and a 60-degree angle, right? Like the smallest side would be this one because it's opposite 50, right? And the biggest one would be the one opposite 70, and that's how that works, right? Those are inequalities. Biggest, smallest, we can figure out the sides that are biggest and smallest, right? Okay, this is talking about 2 triangles that we're comparing. Whatever. There is a concept called the hinge theorem. And then the second concept is the converse of the hinge theorem. Okay? So hinge theorem and converse of the hinge theorem. Do you guys know what a hinge is? Have you heard the word hinge? Yeah, like it's swinging, right? Like a swinging on a hinge, like a door has a hinge, okay? So I'm going to explain this in terms of a door, right? Okay, so this is the hinge theorem in a nutshell. The hinge theorem. In a nutshell, this is what it says, all right? Okay, so what I'm doing is I'm comparing 2 doors to each other, right? So here's what's going to happen. I have this little segment right here, and this is like the entryway of the door, right? This is what I call the door frame. Okay? All right, and then my door is like swinging open. So this is the door itself, and then there's the door frame. Do you see how this is working? It's like swinging like this, right? Yeah? Are we good? Okay, let's say it swings open at an 80-degree angle. For me to come inside, swung open at an 80-degree angle. Got it? I'm going to compare that to another door that's exactly the same size. So the frame of the door is the same width as this frame of the door, right? And the door itself here is the same as the door on the other one, except I'm only going to swing it open like 20 degrees, right? So here's where the door lives, there's where the frame lives. Let's swing this one open just 20 degrees. So it's not open quite as wide. Do we get how this works? This length is the same as this one, and this length is the same as this one. Okay, that's very important. Got it? All right, here is what the hinge theorem says. If I then, like, let's say I put a string on the door handle and connect it back to the door, and I put a string on this door handle and connect it back to the door, which string is longer? Brian did one of these, which means the left one, right? Of course the left one's longer, right? Because that's what the hinge theorem says. It's opening wider, so this opening is going to be wider. This one's opening less, so this opening is going to be less. Got it? Make sense? Now, what has to happen is your door and your frame, we have to be comparing 2 things that are the same size. Like I can only compare the same door and the same door and the same frame and the same frame. For example, let's say, you don't have to write this down, but let me just demonstrate. Let's say here my door and my frame are like this, and this is open at 80 degrees, right? Just the same as what it was before. And I'm talking about this opening. Versus, let's say I have a really huge door and a really huge frame, like that, right? And this is only open 20 degrees. But if I have a big door and a big frame over here and a small door and a small frame over here, even though this is open 80 degrees and this one's only open 20, this one might be bigger. Does that make sense? Because it's a bigger door. So I have to be comparing 2 things that the door and the frame are exactly the same size. Got it? That requirement has to be met first before I can compare the opposite sides. Capiche? Not too bad? All right, let's go to example 1. Here is the example. They try to trick you right off the bat for this one. They're really not very nice. Okay, here's what this says. 2 families set sail on their boats from the same dock. And that is at point L. This is where they're starting from. Okay? And one of the families is going north and one of the families is going south. How do you pronounce this name? This one? The N word? How do you pronounce that N word? It's not the N word, but that N word. How do you pronounce that N
I
word?
wasn't paying attention until you.
Now she's paying attention because I said the N word.
It's like the thing on your elbow.
Yeah.
You know what that's called?
Yeah.
You know
Yes.
what that's
I know
called?
I've seen that before. What is it?
Oh.
It's called. Or is it your knee?
No, I
No.
think this is your weenus.
Yeah.
Oh.
That is your weenus, yeah. But I
think
swear I've
that's
seen
annoying.
that name before.
Noisy?
It's
I
like
think it's like
Nugent or something, where
Or
the
is it
G is
Eugene?
like
Is it
pronounced
Eugene?
later in the word. I don't know.
Is it Eugene?
What?
Eugene.
Nugene? I don't know. Anyway, so the N family, whatever, they're traveling north. This is the N family. They're traveling north. And the Griffins. Then they give us an easy one to pronounce. Whatever. The Griffins are heading south. Okay, now here's the important part.
It's like a Scottish name.
The N family that's heading north, they're going 3.5 nautical miles.
Can I play the pronunciation?
Yeah, sure.
That's not nautical mile? That's like
The Wynn family?
When?
Is that what it sounds like?
Nguyen.
When?
Nguyen. Maybe it's Nguyen. The Nguyen family.
It's obviously like
Ew.
very
Nguyen family. We'll call it the Nguyen
It
family.
is
Definitely not
just
from
because.
there.
Okay,
What's
whatever.
relating this to what you think at all?
What?
do you mean it doesn't look like something from?
It doesn't look like something from Europe.
What? What are you talking about?
From Scotland?
No,
They
from
got all
anywhere
those
from
from-
Europe.
Oh my god.
That is
What are you
not
talking
any-
about?
That is not a European name.
See?
You guys have never. Neither have I.
Okay, so one family is going north. The Nguyen family is going north at 3.5 nautical miles, and the other one is going south for 3.5 nautical miles, and that is the Griffin family. Okay, now that's important. They're both going the same amount. One's going north, one's going south. Got it? Then they are turning. So the Nguyen family is turning 85 degrees, and they're going 2 nautical miles. The other one is turning 95 degrees and going 2 nautical miles. So the important part is, if this is the door frame,
It's Chinese.
it's
But
Chinese.
it's not.
I knew it
African.
wasn't European, Brian.
Okay,
It's literally right next to Europe.
sure.
It's not the same continent.
Okay.
So
Alright.
is Africa.
Shh. Okay, here we go.
That's true.
So the important part is 3.5, 3.5, those match 2 and 2 matches. They want to know, according to the information that they've given us, who is farther away. Which family is farther away? This is the Nguyen family and this is the Griffin family. Which family is farther from the starting point?
The top one.
No, the Griffin.
No.
Away.
Because that angle is smaller. That means that angle is
Because-
larger, right?
No.
Oh, Brian's got an idea. So, they try to trick you to start with. 9 times out of 10, I have people say this one's the longer one because 95 is bigger. But check this.
It's on the outside.
This is on the outside. If that's the outside angle and this is 180 degrees, what's 180 minus 95? 85.
Well, 85.
So the inside angle is 85. Okay, now if this is 85 and this is 180, what's this angle? 95. So when we're actually comparing, we're comparing 95 is going to tell me this side, 85 is going to tell me this one. So who's farther? The Nguyen family or the Nguyen family, whatever, right? Yes? Does that make sense? They gave you the outside angle, we want the inside angle. Now, that is only true because it's 3.5 and 3.5 and 2 and 2 because those other elements are the same. But now we compare the angles and the Nguyen family is farther away. Got it? The Nguyens, the Nguyen family are farther from the boat launch. However you pronounce that word. Okay? Good?
I think one of the weirdest names.
I don't know. It's
We
silly.
should just be generic names that are easy to pronounce.
Right. Exactly. Okay, good? All right, that was, we're gonna skip example 2. Let's go down to example 3, and we're gonna do 3, and we're gonna do the check also. So we'll do this guy, and then we'll do this check down here, and we'll show you how this works, okay? Here we go. Ready? First things first. We have to have our doors match and our frames of our doors match, right? So like if this is the frame of the door, he matches this frame of the door. How do I know that? How do I know that those two pieces are the same? The tick marks. That one, that one. Okay, now, do I have the door itself that's matching the other door? The length. If that's the door frame, does the door itself match?
What's the door?
If this is the door frame, right here, and this is the door frame, where does the door live?
The door lives there.
In the middle.
In the middle. Does that match itself?
Yeah.
Like that door for this side is the
Properly.
same as the door for that side, right?
Yeah.
Okay, so I have the door and the frame, they're matching each other. Now I can compare the angles, right? So this one is this angle and this angle. That's what we're comparing. This is something called the converse of the hinge theorem, because now they're giving me the sides that we're looking at, and now they're telling us what the angles are and compared to each other, right? So 7.3 and 10, which angle is going to be bigger?
10.
The one across from 10, the one that we don't know, right? 3x plus 45, that's what we're trying to figure out. I don't know what 3x plus 45 is, but I know it has to be bigger than 68, yeah? I know that that number has to be bigger than 68. Does that make sense to you, how that works? Hey, he's across from 10 instead of across from 7.3. Okay, so now we just do the math. Subtract the 45. This is not going to come out nicely, but whatever. Subtract the 45. 3x is going to be greater than 23. And then let's divide by 3. Do you know what 23 divided by 3 is? 7.6 repeating. Okay, so x has to be greater than 7.6 repeating. Now, real quick.
It's 7.
What? What did you say?
The other one is the 7.3. Are we looking at those?
No.
Well, then why are they?
What do you mean?
Never mind. Just keep going.
Okay, so here's the deal. We know that this x has to be bigger than 7.3 or 7.6 repeating, right? Now, if it has to be bigger than 7.6 repeating, could it be any number that we want it to be?
No.
Could x be like 100? If x was 100, right, then this is 300 plus 45. This is a 345 degree angle. Could that be a 345 degree angle? Yeah. Matthew says, yeah, of course. Why not? Could it be 345?
It wouldn't look right.
But this is a triangle right here. What's the stipulation about angles of a triangle?
180.
Yeah, it can be greater than 180, right? So not only does 3x plus 45 have to be greater than 68, but 3x plus 45 has to be less than 180, right? It can't be bigger than 180. So we have to look at both cases. Greater than 68, but less than 180. Got it? Let's subtract the 45. 3x is less than like 135, I think. Do you know what 135 divided by 3 is? Brian's got it.
45.
45. So the value of x can be any number bigger than 7.6, but it has to be less than 45, because otherwise we'll have an angle that's bigger than 180. Does that make sense? And we can't do that because it's inside of a triangle. Do you see how that works? Okay. Now the check is going to be just slightly different. Okay. First things first. Do we have a door and a frame matching?
Yeah.
Here's my door frame, here's my door frame, here's the door, and it matches itself. So we've got that going on, and now I can compare these two angles, right? Which one is bigger? Which angle is going to be the bigger one? 55, because he's opposite the 19, right? So one thing I know, I don't know what 3x plus 10 is equivalent to, but I know that it has to be smaller than 55, right? He has to be less than 55. Do you see why that is? Yeah? Okay. Now, let's subtract 10. Hold on to that thought, Brian, because it's, yeah, just wait. 3x is less than 55 minus 10 is 45. What's 45 divided by 3? 15? Okay, x has to be less than 15. Okay, now, here's the tricky part. Are you ready? We're dealing with this as an angle, and we're saying x has to be less than 15, right? We don't have to worry about being 180 because it's already going to be less than, right? So is there a minimum that this angle can be? Not a maximum. Is there a lowest value that this angle can be? What? 0, right? Now, if we say that 3x plus 10 is less, it has to be greater than 0, that means it can't be 0 exactly, right? It could be 0.1 or something like that, right? Whatever. Okay, but it has to be greater than 0. So do you see how we're restricted by the 0 and the 180 also? Okay, so here, we're going to get a negative number for x, I think. Subtract the 10 over 3x is greater than negative 10 and divide by 3. So x is greater than like negative 3.3 repeating, I think is what it is. That make sense? So x can be whatever it wants to be, but it has to be less than 15 and it has to be greater than 3.3, negative 3.3. Does that make sense? Do you see why we're restricted by 0 and 180? Okay, now, on your homework assignment, so we're done with that. On your homework assignment, real quick, I'm going to talk about, I don't know, like number 5. Number 5, real quick. Okay. Oh, ouch. Number 5. This 4x minus 10 is referring to the side, yeah? Okay. I don't know what 4x minus 10 is, but I know it has to be what in relationship to 40? Bigger. How do you know it has to be bigger than 40?
Because 120 is bigger than
120 is bigger than 115. Cool. Now, you solve that, you get that, right? X has to be greater than whatever. Does this side have to be smaller than something? Are we restricted by a side having to be smaller than something? I don't think so. A side's not going to have an upper limit like an angle does. An angle has an upper limit of 180, but a side can be as long as it wants to. Now, is there a minimum value that a side can have?